Alright, so we have been talking about solving systems of equations. Today we are going to talk about solving systems of equations by substituting. So we have our first example written down. Find the solution of y equals x minus 3 and 2x plus y equals negative 3. The first step that we need to do in order to solve this system is we have to substitute. What does it mean to substitute? Mohammed? Okay.
Trade something for something?
Okay, trade something for something. So I have a y equals x minus 3, and then I have 2x plus y equals negative 3. We've taught you how to solve equations before, but there's only been one letter in the equations, right? Have you ever had equations where there's an x and a y at the same time?
Wait, I think what, you mean both on the sign?
I just asked if we've ever had equations where we've solved and we've had x and y all in the same equation.
I think have it singular.
We had all x's. Sometimes we had them on the left and the right, or we had all y's, sometimes the left and the right. We never had two different letters.
I think we have.
We have?
Yeah, for the graph.
When we're graphing, we've had this, the slope-intercept form, right? And we've been able to graph that.
Yeah, but we also had that one where we also saw. But we've also had that one.
Okay.
What's that one?
All right. Well, we're gonna do substituting. So if I want to substitute for this, does anybody know what I would substitute for this y right here? I don't want that y anymore. I want to take that y out. I want to replace it. What could I substitute in its place? Aim? 0? We did 0 when we were finding intercepts. We could do that if we wanted to find out what x was when y was 0. But I have two equations here. So I want to use these two equations. What is the first equation telling me y is?
Oh.
Kayla? It's not telling me y is negative 3. It's telling me y is x minus 3. So that is what I'm going to do first. I am going to substitute. What am I going to substitute? I am going to replace the y in the second equation with x minus 3, because I know from the first equation that y equals x minus 3. So I'm going to write 2x plus y equals negative 3. But step 1 tells me to substitute. So instead of y, I'm going to rewrite 2x plus x minus 3 equals negative 3. I took out the y and replaced it with x minus 3. Because the first equation told me that y equals x minus 3.
Oh, I get it.
So now I have just a simple equation that we did in chapter 2. I'm just going to rewrite it underneath here without the parentheses. I had the parentheses because I wanted to show you that I replaced it or substituted it, put it in that place. Now I need to solve this equation. What's the first thing I need to do in order to solve this equation? The first thing I need to do to solve this equation. What do you think?
Combine the like terms.
Combine the like terms. And what are the like terms?
2x and then 1x.
Very good. You need to combine 2x plus 1x. And you can just combine them. You don't have to move them because they're already on the same side. So now I have 3x minus 3 equals negative 3.
Wow.
Now it's a two-step equation.
I got it.
What do I do now?
The answer is,
What do I do next?
you have to do
Plus 3 to both sides. That cancels out, so I have 3x equals 0.
But that's not true, because
And the final step, 3x equals 0. What do I do last? Divide by 3. Somebody said it? Good job. Divide by 3. Good. X equals 0.
Wait. Can't you have 3 times 2, 6 minus 3 equals,
It's negative 3 plus 3 is 0. So this is where your calculators are definitely going to come in hand. You didn't need your calculators when we were graphing, but you are going to need your calculators now. So what we did is we substituted, and then in this step, we started to solve for x. And now the next step is we're going to use this. We're going to substitute again. So it's substitute, solve, and now we're going to substitute again. Substitute. Back into the first equation. So we substituted y, got rid of y and put in x minus 3. Then we solved for x. Now we're going to substitute again in the first equation so that we can solve for y. Alright, so, pile of papers. Now I'm going to take this and I'm going to work over here because I ran out of space. The original equation, the first one, said y equals x minus 3. So I'm just going to rewrite that from above. Y equals x minus 3. I want to substitute in 0 for x. So y equals 0 minus 3. What is the value of y? Negative 3. Yep. So now I have an x and I have a y, which means I have an ordered pair and a solution. So the solution to this problem, find the solution, is 0, negative 3. That is our solution. What does the solution mean when you're solving a system? What is the solution?
Find where the lines intersect.
Okay, so now let's check and see if I really did this correctly. So my first equation, and I'm just going to graph it. You can just watch because we're just going to do this as a check. You don't need to graph it. The first equation was y equals x minus 3. What's the y-intercept? Negative 3, and the slope is 1. So I'm going to make all the dots for a slope of 1. So that is the first equation. The second equation it's written as 2x plus y equals negative 3. So it's really y equals negative 3 minus 2x. So where do I start?
Negative 3.
Negative 3. Oh, I happen to start on negative 3 with the other one. Down 2 over 1, down 2 over 1. And now I have my second line. That's one line, sorry. This is the other line. And what's the solution? The solution is the point where they meet, which is 0, negative 3, which is the same answer we got by substitution.
Yeah. Wow.
Let's try another example. y equals 2x plus 10, and y equals 4x minus 6. So substitute, solve. Substitute, solve. That's how you do this. It's basically 2 steps and repeat. So the first step is telling me that I need to substitute. So does anybody want to tell me what I should do for that? How should I do that? What should I do?
For the second equation, substitute the y for 2x plus 10.
Okay, so put 2x plus 10 right there. Very good. So we are going to use 2x plus 10 instead of this y. So I have 2x plus 10 equals 4x minus 6, because y equals y. So step 1, substitute. Step 2, solve for x. First step. How do I solve this? Ashley?
Subtract 10 from both sides.
I could. Sure, I can subtract 10 from both sides. That's fine. So now I have 2x equals 4x minus 16. I do want to do something with 4x. I heard somebody say that. What do I want to do? Subtract 4x from both sides. So now I have 2x minus 4x, which is negative 2x. Please do not forget the x. Equals, what's on this side? Negative 16. Do not forget the negative. Now I divide both sides by negative 2. So x equals 8. So now I solved for x. So I need to, step 3, substitute. And step 4 is solve for y. It does not matter which equation you pick. I'm going to choose the first one. It really does not matter though. So I'm going to write y equals 2x plus 10. But instead of x, I'm going to substitute 8. So y equals 2 times 8 plus 10. What is the value of y? 26. Thank you. Y equals 26. What is the solution?
Negative 826.
The point is 8, 26. If we were to graph it, this is the point on the graph where they would meet. 8, 26. You're going to have to trust me on that one because I don't have a graph that big right now. Questions on the steps? Substitute, solve, substitute, solve. No? All right. Now I'm going to give you an example to try on your own. So if you're watching this video, you should pause the video and try it. Here is your example to try. Y equals x minus 1 and y equals negative x plus 3. Pause the video and solve it. Okay, let's go through this problem and see how we did. I am going to substitute in for y equals x minus 1. So now I have x minus 1 equals negative x plus 3. I want my x's on the same side, so I'm going to add an x to each side. So I have 2x minus 1 equals 3. I'm going to add 1 to both sides. So now I have 2x equals 4.
Yep.
I want to get x alone, so I will divide by 2. So x is 2. That is the first part of my ordered pair. The second step tells me to substitute. I'm going to use the equation y equals x minus 1. This is the first equation from right here. I'm going to substitute for x, and I'm going to use 2. So now I have y equals 2 minus 1, so y is 1. But I am not done, because my final answer should be written as an ordered pair. And the ordered pair that you should write is 2, 1. That is the solution. Oops. 2, 1. I know, I added extra parentheses. All right. Next example, we're going to do this one together. Yeah.
Yeah, so basically got the same exact answer, but
All right. Next example is y equals negative 3x minus 3, and y equals negative 3x plus 3. Anybody notice anything about these two equations? Y equals negative 3x minus 3, and y equals negative 3x plus 3. Tamia? They have the same slope and different y-intercepts. So what does that mean, Tamia? Okay, what does that mean?
it's going to be parallel because it says, from the definition we wrote a day ago, it says when it has the same slope and different y-intercepts, it's automatically parallel.
Very good. And if it's parallel lines, what does that mean about the solution? There is no solution. We know that, so let's see if that's what we get when we substitute. I am going to rewrite this and have negative 3x minus 3 as this y. So I'm going to write negative 3x minus 3 equals to negative 3x plus 3. I'm going to add 3x to both sides. Now I have negative 3 equals positive 3. Does negative 3 equal positive 3? No. So I'm going to put a big line through that equal sign. These are not equal. If they are not equal, that means...
No solution.
Very good. No solution. If we want to elaborate, we would write parallel lines. If you wanted to elaborate further, like they'll ask you to do on the park. This system, y equals negative 3x minus 3, and y equals negative 3x plus 3, has no solution because the lines have the same slope and different y-intercepts, which means they are parallel lines and will never touch. Good. And one final example. Y equals x plus 2, and y equals negative x plus 3. Oh wait, we did that one. We did that one.
No, it was 1. It was negative 1.
We did that one.
No, we didn't. It was negative 1. It was x minus 1 and negative.
Alright, here's the example I decided to change it to. Y equals x plus 2. X minus y equals negative 2. So y equals x plus 2, and x minus y equals negative 2. So what does y equal? What does y equal?
X plus 2.
Good. It equals x plus 2, so I'm going to put in x plus 2 here. So x minus, and I'm going to put this in parentheses, x plus 2 equals negative 2. There is a reason why I substituted in using parentheses. The reason is this subtraction sign. This subtraction sign is kind of like having a negative 1 outside of the parentheses that needs to be distributed. So it's x minus 1x minus 2 equals negative 2. I had to distribute a negative 1 because there was a subtraction sign in the problem. So I did negative 1 times x, and I got negative x. Then I did negative 1 times 2, which was negative 2. Yeah.
How do you get the 1?
This was just a negative, so I just added in that imaginary 1 that haunts all of us. Just that imaginary 1, because I had to distribute a negative. So, if you look back in example number 1 when we substituted, it was a plus, so we didn't have to distribute a negative. But this example has a negative, so you have to distribute negative 1 to both terms. What is x minus x? 1x minus 1x.
0.
That's no x's, right?
Yeah.
So now I have no x's, but I have a negative 2 equals negative 2. What does negative 2 equals negative 2 mean about this system?
Infinitely many solutions.
Exactly. Infinite solutions. It's an infinite amount of solutions because that means every point will match up. I'm going to show you. I'll graph it so you'll see.
How did you get the parentheses?
I used the parentheses for what I substituted in. So see what's in the orange right here, the x plus 2? I just put that inside parentheses. When I substituted it in, I just used parentheses. I did that because there was a subtraction sign there. And I needed to. I had to distribute a negative. It's a little tricky. If you look at this problem, and I want to get y by itself, I could subtract x from either side. I have negative y equals negative 2 minus x. Divide by a negative 1 for everything. So y is 2 plus x. Is that the same thing as the first one? Those are the same, right? That's why it's infinite. So if you don't believe the math, like when you substituted it and did it, you could always just solve for y. And when this is written in slope-intercept form, they both have a slope of 1. They both have a y-intercept of 2.